We decided in the previous session that we need a new alphabet if we're going to study speech sounds seriously. That new alphabet is the IPA. Well, the IPA is based on the study of articulatory phonetics, which is the study of how speech sounds are produced. In order to understand how speech is produced, we have to look at your anatomy. And in this session, we're going to do that. We're going to have a good look inside and check out what's in there and how it's put to use in speech. Of course, to do that we have to look at organs. You all know that there are organs in there. There are kidneys and livers and there's a heart and stuff. Some of these are useful for speech. Your kidneys aren't particularly useful when you're talking, but it turns out that your lungs and your tongue are jolly useful. Speech is produced by a variety of these internal organs, and they are also used for other purposes. In fact, they were used for these other purposes well before humans started speaking. We know that because other creatures have exactly the same organs and they're used for the same purpose that they're used for by humans. So the lungs, for example, are for breathing. The fact that they're also handy for speech is an overlay. It came later and we still use it for breathing. If you can't breathe, you can't speak. And those who don't breathe, don't speak. Well, we've also got a windpipe. The windpipe is used for conveying air from the mouth into the lungs, and we'll find that that has its uses in speech. There's a set of vocal cords at the top of our neck, and these vocal cords are very important for speech, but before that they were useful for swallowing. They prevented food from going down your windpipe. Essentially they're a valve, and they are used as a valve by other creatures that don't talk. We have a mouth and a nose, very handy when you're talking, but also handy when you're eating, and noses are very useful for blowing, and also of course for breathing when you're eating. Just think what would happen if you had a mouthful of food and you gradually found that you were getting shorter and shorter of air. Well, that's taken care of by the fact that you can breathe through your nose at the same time as your mouth is full. So let's have a look at these organs of speech and see what they look like. They are essentially on this diagram represented by cutting the human body in half down the middle. You mightn't be able to recognize yourself here. You have no hair, but you've got a spinal column that you've probably never seen, but there it is at the back, and the rest of it we're going to have a look at. Right down the bottom of the diagram we've got a sort of cavity, and this cavity holds your intestines, and on the outside of it there are abdominal muscles. Your abdomen has a sheet of muscle around it, and you can tighten that and you can check it out yourself. Make it good and tight and give yourself a thump and you'll see where it is. In the middle of the torso, essentially, there's a diaphragm which goes right across the whole of the human body. It's attached to the spinal column at the back and to the breastbone, sternum at the front, and it runs right across as a single sheet of muscle. It's a very strong set of muscles, and it's essential for breathing. When you breathe, the diaphragm raises and lowers. When it lowers, the cavity at the top, the chest cavity, expands. There's more volume in it. As a result, air has to come in and equalize the pressure that's been created by creating this little bit of a vacuum, and when it does that, air enters the lungs. It comes in your mouth, goes down your trachea or windpipe, enters your lungs, and at that point the carbon dioxide which has been built up in your vascular system is exchanged for oxygen so that you can burn oxygen to keep your body running. We have to keep temperature up. If we were lizards, we'd be in better shape. All we'd need to do is sit on a rock for a while to warm up. But humans have to regulate their body temperature very closely, and to do that they have to burn food, and one of the ways of doing that is to use oxygen being vital for keeping us at a regular body temperature, among other things. Okay, so the diaphragm lowers, the basic chest cavity gets a bit larger, air comes in, and then the diaphragm raises, the chest cavity becomes a little bit smaller, and the air goes back out. So essentially what we do when we breathe is we breathe in, we breathe out, and then we have a rest. Try breathing. Breathe in, breathe out, have a rest. That's what we do all the time. Waking or sleeping, we breathe all the time. When you stop breathing, that's the end, really. Well, the windpipe we've already seen has the fancy name of trachea, and it's a pipe for conveying air down through your neck. At the top of it there's a device called the larynx, and the larynx is essentially a valve which is in almost all other animals that have one, there to prevent food from going down your windpipe. You can imagine if you took in half a dozen chips and they all got stuck down in your windpipe, by mistake of course, then unfortunately you would choke to death. And this does still happen. Occasionally some food gets stuck in your larynx, and the way to get over that is to cough it up, or if things are really bad, someone gets in behind you and presses very hard on your abdominal muscles, forcing the diaphragm up, which again forces the air out and hopefully dislodges whatever's there stuck in your larynx. A little bit further up you'll see something called the pharynx. That's also a piece of tube. It's a joint tube that conveys air at the front end, but it also conveys food down the back. As we'll see later, behind the trachea there is the esophagus, which conveys food down to your intestines, which we've already talked about as being down the bottom end there in the bottom cavity. So essentially you can see the top cavity as an air cavity and the bottom cavity as a food cavity. But the air and the food both have to come in the same way, that is through your mouth. The oral cavity, of course, is essentially the cavity in your mouth, and the nasal cavity is the cavity in your nose. Let's take a closer look now at the top end of that. Here's a splendid gentleman, and we don't know what his name is, but he's clearly Western, and he's clearly, well, rather dashing. You can see where his larynx is, and yours is in the same place. You can actually feel it when you put your fingers on the front of your throat. It's the Adam's apple is the front of it. You can actually feel it there. And then you can see the joint bit, which is the pharynx, this single tube, and then it splits at the top into this gentleman's oral tract and his nasal tract. Well, what does that look like when we look at it more closely? Well, here's a mid-sagittal section, rather more anatomically correct. It's not just a diagram, it's closer to the facts. And this is just the front of the bottom bit of your head. And now we can see a lot more detail. At the back, on the right, you can see the top end of the spinal column. The vertebrae are clearly seen as the slightly dotted sections at the back there, and immediately in front of that is the esophagus. Starting at the bottom you can see the little red line. It says esophagus, and the esophagus is essentially a tube for conveying food from the mouth to the stomach. In front of it you can again see the trachea, the windpipe, and you'll see that the air goes round a corner, whereas the food sort of goes straight down. Well, that's very convenient. The air is good for going round corners, and food is better dropping straight down because it is subject to gravity. So when you're standing upright or sitting upright, the food sort of only has to drop down from the back of your tongue when you're eating. Then we can see where the larynx is, and you can see that it's just at the top of your neck, and it's covered by something called the epiglottis. Epi meaning over the top of the glottis. The epiglottis is a way of preventing food from going down into the larynx and the trachea. And what I'd like you to do now is just hold on to your Adam's apple and swallow. Hey, that was funny. You'll notice that the Adam's apple jumps quite a big distance when you swallow. Why does it do that? Well, the larynx goes up. At the moment that it goes up, the epiglottis folds over the top of it, because the whole point of swallowing is to get food to go from the back of the mouth into the esophagus. So what you don't want is for the food to go down into the larynx, blocking it up and causing you to choke. So swallowing is a way of getting the trachea and the vocal folds closer to the epiglottis, which can then cover them up, preventing food from going down the wrong way, down the wrong pipe. Okay, so what's the point of all this? Well, we have to wait a while until we get to speech, which we will. Carrying on up, the next thing you see is the uvula. We're now in a position where you can actually stand in front of a mirror and see some of this stuff. You can't see your own vocal folds unless you get a mirror, a dental mirror, and then you can see a little bit down the back of your throat, but it's quite difficult. You actually have to lower a camera down there, and that's been done, but it's you tend to gag when you do that. The uvula is the little blob of tissue that you can see at the back of your throat if you open wide and do what the dentist asks you to do, which is to say, ah. When you say ah, your tongue is down as far as it can go, and the dentist and the doctor can then see right down the back of your throat to see if you've got any redness if you're a doctor, or how your back teeth are doing if you're a dentist. Beyond the uvula, you'll see that there's a soft palate, and you can actually feel this by putting your tongue back in your mouth, and you'll see that there's a hard bit to start with. You can feel it on the roof of your mouth, the hard palate, and beyond that things get soft. Well, the reason is that the hard palate has bone on top of it. There's bone inside, and the palate is just some skin and tissue sitting over the top of that. But the soft palate is just muscular tissue. The soft palate has an interesting capacity. It can go forwards or backwards. You can see from the diagram that if it were to go back, it would actually touch the back of the throat, and it would block off the air supply, and it can do that. It's another little valve, just as the vocal folds are a valve. When the soft palate moves back, it blocks off the air supply to your nose. When it moves forward, the air can go out of your nose. So when your mouth is shut, which it is from time to time, and you breathe in through your nose, then obviously the soft palate is away from the back of the throat, and the air is able to get through to the trachea and your lungs, and you continue to breathe. Up above the palate, you can see there's the nasal cavity, which is quite large, and there are some nice little holes above it in the bone, and these are your sinuses. Just in case you wondered where they were, well, that's where they are. They're your nasal sinuses. And beyond that is your brain. Your brain sits in the cavity beyond that piece of bone in the rest of your skull. Your skull is largely filled with brain. We have very big brains. We're a big-brained kind of animal. Don't start to feel too self-satisfied. Some people use it better than others, but you do have one. It's a very big brain. At the bottom of the mouth you'll see there's the tongue, and the tongue is divided into zones. The back of the tongue sits opposite the soft palate, the front of the tongue sits opposite the hard palate, and the blade of the tongue sits opposite the alveolar ridge. Now, we haven't talked about that, but again, you can feel it with your tongue. Bring your tongue up to your teeth, and then just above your teeth, top teeth, you'll feel a hard, bony sort of ridge. Right? This is the alveolar ridge, and it's used to keep your teeth in. Obviously, your teeth have a lot of work to do, and they have to bite things, and so they have to be well embedded, and so there's quite a bit of heavy, dense bone to keep the teeth in. Well, some of that bone is the alveolar ridge, which is bracing for your teeth. Your teeth are obvious and your lips are obvious. Anybody can see those. The tip of the tongue is the extreme front end, and if you poke your tongue out you can see it. It's the very, very tip of your tongue. Well, all of those things turn out to be important for speech. But probably the most fascinating of all of these organs is the larynx itself, the little valve that we use to make voicing, essentially. We also use it for opening and closing the airway to the larynx. At the front of the larynx is the thyroid cartilage, and you can see a little piece of it there. It carries on all the way, but this only has the front of it there. And attached at the front of it are two flaps. They're very, very small flaps. They're a centimetre or so, and they're attached right at the front. At the other end, they're attached to two little cartilages called the arytenoid cartilages, which you can see there. There's a pair of them, and they're hinged. They're hinged on the cricoid cartilage, which you can also see down there. There's only part of it showing, little round circles. These cartilages are very small indeed, but they have very sensitive muscles attached to them. When the muscles pull in one direction, the two flaps open so that there's more room for air to go in. And if you look at the heavy dotted lines, which are at the extreme of the travel that these little cartilages can do, then when they open you get more space between these flaps of tissue, and the air can get in between. More air can get in between. When they're in neutral state, and that's how you see them in the diagram, the muscles aren't operating at all. When the muscles pull hard in the opposite direction, they can close the flap off altogether. That happens with weightlifting, for example. You can hear weightlifters when they're taking the strain, they grunt a little bit at the end. That's a little bit of air escaping. The air has to be kept confined to their chest cavity, because when you're lifting heavy weights, if you didn't keep your little larynx valve shut, well, your lungs would collapse, because the muscles at the back and at the front of your chest cavity would completely cave the whole thing in, and you'd end up winded. So when you're carrying heavy weights, you have to shut the larynx off, creating absolutely tight closure, and that's done by pulling on these two little cartilages and getting the two flaps of skin, your vocal folds, close together. Vocal cords, they're sometimes called vocal folds and sometimes vocal cords. The larynx is an incredibly sensitive instrument. The small muscles that pull on the arytenoid cartilages can pull very hard in both directions, creating a very large space for the air to get through, or no space at all, and then they can adjust themselves very sensitively so that the cords are only just touching each other, and then when the air goes through them, what you get is voice. Voice is vital for speech. Without voice, speaking is just about impossible. We're going to have a look in greater detail at what the larynx does when we start to look at voice.